Welcome to Programming with Qt Widgets. In this episode, we will look at a concept in Qt called properties. If you have any experience with QML, you will definitely know what a property is. But what is it in Qt Widget? Stay tuned and I'll let you know. So what you're looking at here now is Qt Designer. We saw that in module number 2 of this series here. And if you haven't seen that, now might be a good time to go back and see it. What you'll notice here in this sidebar, and hopefully it's no surprise for you, is that you can configure this checkbox here that's called checkbox. What a great name for a checkbox. And among other things, you can configure the text to be by ice cream. And you will likely have guessed by now the checkbox has the text called by ice cream. But that's not the end of the game. What will happen when I press compile is that I will get a header file for this UI, and in that header file it will say set text by ice cream. How's that possible? Okay, not that bad. Not that difficult. I mean, we know that the property is called text and that it's called likely set text, the method for writing it. And yes, that is one of the beauty of Qt, namely that you can be pretty sure that when the property is called text, then the setter is called set text. And if it's called style sheet, then the setter is called set style sheet, and so on and so on. But how does it know that the parameter is a string? Well, it could be a Boolean, as in set autofill background. That should be a bool, or it could be this enum here, left to right. So how does it know that? Well, again, there's more than meets the eye. In Qt, there is this whole concept of a meta object. We've seen that earlier on. That's how the signal slot mechanism works. For example, that it has this meta information about the objects. That's what you get with Q_object. And if you haven't watched the behind the scenes tours, now might be a good time after you watch this one here to go back and review that one. There I'll go into much detail on what is actually happening with Q_object, for example. But how about if I scroll all the way down here? No, not here. Here. This plus gives me a new property. And this new property, I can call it Jesper. That is a great name for a property. And okay, and it's a string. And the Jesper is hello. What will get generated into the file for that? And how will it take this concept of a property and get that into my executable? Well, that's what we'll dive into in this very episode. Let's go to QML for just a second. I'm sure that even though that you are a Qt Widgets developer, that you sniffed a bit at what is QML. And in QML, I will write stuff like text, so with a capital T, open brace, and then text : hello world, and close brace again. That's my equivalent of a Q label in QML. But that is written in a file that has absolutely nothing to do with C++. It's a file that C++, the QML engine, will open and read. And it will see that there is text with a capital T, and it will come to the conclusion, I better create on the C++ side of things a text element. However it does that, well, I know, but I don't want to bother you with the detail. And you see that there is text : that's a lowercase t, so text : hello, and that's the property. So now it has a property called text that has the value hello, and it needs that to go down to the element. How is that possible? We don't have a way of calling methods in C++ based on their names. That's Bjarne Stroustrup deciding 4 or 5 decades ago that that would be wasteful to do. That's what Java has, but we don't in C++. But we do, to some degree, with Qt because, again, of the Q underscore object macro. So how is this possible in C++? Well, on my Q object subclasses, again, the Q underscore object macro needs that to start the whole thing. But on those classes, I'll be writing code like this. Q underscore property, the name of the type of the property. That could be like Q string. The name of the property, text, a method, or the letters read spelled out, and then the method name, I will read it. Write spelled out like this, W-R-I-T-E, capital letters, and a function for writing it, and a bunch of other things. And go and put your cursor in QCreator on Q underscore property and follow it. Then you'll see the documentation for each of these. So what does that give us? Well, that gives us some code written into the mock file. And in the mock file, I'll now have the possibility of setting a property and reading a property. And these are two methods of QObject. And notice I told you upfront, subclass from QObject, or of course one of the QObject subclasses, and then you have access to properties. The property method, what that one does is that you call into mock, and mock will have code generated for reading, or for calling this there we are, this get function here whenever I want to read. So property, call the get function, and write, call the set function. And here's our little friend QVariant, and up there is QVariant because, well, the property method do not know exactly what will be returned. In general, it could be that I have a property called text that returns a Q string, or it could be a property called enabled that returns a Boolean. As you saw in Qt Designer, you can do dynamic properties, and that's simply properties where the object doesn't have a name of that type already. Then it's a dynamic or a custom property, and there's one cool usage of that, but I'll get back to that in just a second. All of this works because of the introspection that QMater object and QMater property gives us on the object, and I have a slide that shows exactly those in a few minutes. But again, note Q underscore object, or if it's not a Q object subclass, if it's a value class, I started saying Q object, but you can also get this working for value classes, then you need Q underscore gadget. Yeah, I know that was wrong, and let me just correct it here rather than just re-record that last tape, because there's some insight here. I told you that you could get this working with Q underscore gadget, but obviously, so first of all, if you subclass from Q object, then you create an instance of that object as a pointer. You cannot create you could, but Q object, usually you work with those as true pointers. But if you have a value class, something that is a value like a Q string is a value or Q point is a value, and you want those to go over a boundary like to QML or with dbus or whatever, then you'd need a gadget, and that's where you add the Q underscore gadget. Obviously, the property and set properties, two methods that are on Q object, so they are not available there. But this whole concept of properties are still, and that's how you can, with a gadget, with a value class, so something, a struct that doesn't subclass from Q object, and which you can copy around, you can still get that to the QML side and access information from it via its properties. At least it cleared it for me. Hope it did for you. Otherwise, let's ask Jesper for a small ad. We all know how it goes. A few lines of experiment and then it grew on you. And now you have a huge application in Python that you want to migrate to C++. Talk to us. We can help you. We have experts both in Python and in C++ and in the migration process. So now I have an example for you. This example makes much more sense in the context of QML, where you on the C++ side have a customer and then you want to represent that as a record on the, or as a data structure on the QML side, it doesn't make much sense in the context of Qt Designer as we started out with here. But bear with me. When I say customer, just think of it as a custom widget. It could be a compass widget, for example. And the compass widget would have a number of properties, whether it should be pointing to true north or to the magnetic north, whether it should be, and a lot of different properties. And that, with that in mind, let's just see how you create an object that has properties. So I subclass from QObject. I have the Q_object macro, and here comes all my Q_property macros. And if you're sitting there saying, how can this even be valid C++? Well, don't worry, it is not. This is not valid C++. This is just a macro that will take all of this and on C++ side goes away. But we have a little friend, namely mock, that will read this. And for mock, it makes a lot of sense, and mock will generate stuff into the mock file based on this. So I have a bunch of properties. First, the type. So here, QString, that's type, QString, a QDate, a customer type, whatever that is. Well, that was an enum. I can see that down here. Then the name of the property. So I can read this property with the name. I can read this with the name, address, and so on. Read, so get, if I want to read the property, then call this get method, and or get name. You can see that's the one we have down here. It takes, or it's a const method, and it returns a QString. If I want to write it, set name, we have that down here. Do not return anything, takes a const QString, calls a QString here, reference name. Notify, that's again, this is from QML land, but this allows, whenever that property is changed via the property system, it will emit this signal called name changed. On the C++ side, you would expect that it said void name changed and then the new name. Of course, that's how we do it in Qt Widget, but in QML, all they need to know is that, hey, it changed. But this is not a QML training, so don't worry too much about that. You will also notice an example down here, QString phone, and then there's member m_phone. And when it says member m_phone, that is behind the scene creating a reader and a writer for phone that goes straight into our m_phone method down here. QDate is constant. I guess it would change over time, but I guess they expected that the application, well, no, that's the date the customer relationship was established. That, of course, do not change over time, so it is constant. And here we have an enum, and I wrap my enum using Q_enum, and when I do that, that gives me access to the enum via the property system too. Yes, now I remember my thought. One thing that is not necessary is that your property actually has access to a member variable. I could easily have a property that was called current time that would just go and read the time from the system, and if I was calling set time, then it would update the system's time. So there's no member variable behind it, but usually there is. I'll promise you that it'll get weird from now on, so stay tuned with being prepared for weirdness, because I'm going to show you code that you would never write, but nevertheless, what I'll show you is how this property API actually works. So imagine that I have a customer now, and we saw the customer on the previous slide. My customer, I can set the address to be this address here. This is the complaint division on Series B, and bonus points for the first one, who in the comment below can tell me where this is. Anyway, I can go to my customer here, and I can ask for the property address. So I have a customer, and of course I could just go to customer and call address, because it obviously has an address method. Check over here, my customer has a get address method. So obviously I could just go and call that. But instead I can also go and ask for the property address. And what will that return me? Yes, you're right, a Q variant. I can also go and and create a Q variant here with something, and then set property name with this Q variant name that I have here. So that's how I can read and write properties. And of course, my asserts down here just tells me that, hey, yes, they are the same. And go and look at this example here if you really truly do not believe that this code works. Now I would like to show you something, and it just gets weirder and weirder. What I will show you now is a class that can more or less, or a method that more or less can print out the construction of an object. It's given a QObject pointer here, and it will return a QString list. It will actually return a QString, but it will build it up in a QString list. And what I'll do is I'll go to my object and I'll say, can you give me the meta object? And remember, the meta object is meta information about the object in a QMeta object class. So it has a number of methods that tells me information about objects, namely this one here. And in my result, I will add class something, :public something, opening brace. And that something is the meta object class name, the meta object superclass pointer class name. So that way I can go and ask an object for what is your class name, and even what is your superclass name. And that's what I print here. Then I iterate through meta object property count. So I ask for how many properties do you have? And again, this is information that was written into the mock generated file. And I urge you to go and look at some of your mock generated files to see that these kind of information is in there. It's rather well encrypted by now. By now means in Qt 5.6, in the Qt 2 days, it was rather easy to read. But anyway, in there is information about how many properties there are. So I'll iterate through this amount of properties, and I'll go and ask for the properties, the ith property. That'll give me a QMeta property information. And I'll go and ask now the object for its property with this meta property dot name. So I have an object representing a property, and I can go to that object and say, what's the name of that property? And that's the value that I get back. I'll take that value, and what the value returned is a Q variant, and then I'll add to my result here. That's the string list, namely space %1, %2 equal to %3. And what these are is meta object, meta property dot type name. That was the meta property here. It's type name, so that would be QString, or it would be bool, or whatever it was. And meta property dot name, that's the same you saw up here. So that's the name of that meta property. And then value dot toString, that's the value I got from calling this. I'll append close, and I'll return the whole thing with joined with \n. And let's see what it runs out. Well, let's go and see our main here. Let's go and see our main, which is called, so what you see here. This is my object toString. That's the one I just showed you. And then in my main, I create a QGUI application, and I set the organization name, the application name, the organization domain, and then I call this object toString, the one we just saw, on the application itself, because QGUI application is also a QObject subclass, and print it out using Qdebug. And what you can see up here is start here class QGUI application :public QCore application. Well, that's a GUI application there, core application, and it has a QString object name that is nothing, so there was no object name specified. It has application name test properties. That's what you see right up here. It has application version not set, organization name, Qt project. That's what you see up there. And at the end, closing brace. And obviously, this example has no real world value, but it gave me a possibility to show you how to traverse the API. That was pretty weird, wasn't it? Well, let me end this episode and this whole module with a real world example. I just took it out of some code I wrote just today, and I'll cut it down a bit so it's easier to grasp and you can go play with it. So what is the code about? Well, let me start running the user interface so you can get an idea for what it what it looks like. It looks like this very simple user interface here. I have a list of 3 names, and when I select some of them and press go, it will print out down here on my command line, or wherever I called it from. It'll print out a number and the name next to it. Okay, what is this all about? Well, the 3 names simulated 3 teams from KDAB, and a team is actually a record, or a struct to be more accurate, of some data. Among other, it's a name of the team. The team is in a database with a database ID, and there is team members and lots of other things in these classes, or in this struct in this example here. So I have a class or struct that is called team, and that's where we start. You can see here, struct team, very simple ID and a name, and I have this using here that gives me a list of teams. That's my teams. Let's get back to this declare meta type in just a second. So that's my team. In my main, I call on a class called team selector. I call the method get teams, which returns me a list of these teams. Well, we could even call it teams here to make it easier to understand what's going on. So this gives me a list of teams, and I run through this list of teams. I print out the team ID and the team name. Okay, so far so good. What's going on in this get teams? Well, here is the hard-coded 3 teams that we have. Of course, I would get that out of a database and blah, blah, blah. That's not the interesting part. The interesting part comes in here. So this method get teams, what it does is that it has a list of checkboxes. That's the checkboxes that you'll see on the screen. It creates a layout on this class, because this class here, as you see over here, is a QDialog. I create a layout on that, and that this is where the layout works on, and it's a vertical layout. Then I iterate through each of my teams, and for each team, I create the checkbox with the team.name. I add the checkbox to my layout. I remember the checkbox, and then there's this line. I'll get back to that in a second. I create a button here that's a button called go. Whenever it is clicked, it accepts, which closes the dialog, and then I call exec, which makes the code stop here until the dialog is done. That's the recursive event loop that we've seen a number of times. Here's my result. I run through all the checkboxes, and if the checkbox is checked, then something again here. And this line here and that line up here are the magic lines of this whole thing. Because what I do here is I set a dynamic property. So team is not a property of QCheckbox. You can go and check the API if you don't trust me, but it is not. It's a dynamic property. And I take my team that I have up here. That is an instance of the struct team from QVariant from value. Now I took the team and I wrapped it into a QVariant, which can be put as a dynamic property on this checkbox. And later down here, if it's checked, then the result, I'll go to the checkbox, I'll ask for the dynamic property called team, and that returns me a QVariant. So .value will take the team out of the variant. That is truly super useful. The alternative that I've seen in many different incarnations over the years is that I would have a list of checkbox, or I'll have a mapping from the checkbox to the actual team that was in there, or I would somehow else be able to map between the two. But now I'll just take my team, put it in as a dynamic property of that checkbox. And finally, I had quite a bit of a surprise when I wrote this code, because I forgot the Q_declare_meta type, or actually I did not forget it. I did have it in there. I had some other problems that was completely unrelated to this. Well, I forgot to call the QVariant : from value around the team over there. So it complained about weird things, and then, yeah, of course, that's what I need. And then I started, well, I added a QGadget here, and I added the Q_declare_meta type here in an attempt to get it working, and then I realized, maybe I do not need it, so I commented it out. And let me just try and do that for you here. And we need to go over here in our project. It's this run configuration. This is Qt 6.6.2, which is the current version as I'm recording this. And you can see it works out just fine. Now let's go over here and run it with this one. This is Qt 5.15, the latest version of the Qt 5 series. And now you can see static assert type is not registered. Can I make this bigger? I'm sure I could make it bigger. Whatever. It says type is not registered. Please use Qt declare meta type macro to mark it known to the Qt meta object system. So in the last episode, I told you, hey, you need to call Qt declare meta type around your public types or your own types if you want them to be able to go into a Q variant. I was actually somewhat wrong, at least if it is a modern version of Qt that you're using, namely a Qt 6 or Qt 7, Qt 8, whatever it is when you watch this. But if it's Qt 5, then I was entirely right. Then you need the Q underscore declare underscore meta type. And that concludes this module here on the core types in Qt. I hope you enjoyed it. As always, please do follow us, give us thumbs up and follow and all of those things. And even more important, come to us with all your business so that I can still get a salary and be able to create these tutorials, which I enjoy very much. I hope you enjoy them as much. If not, or even if you do, until next time, have a great time.